The next series of reactions are going to include 4 reactions, and they all involve a common theme, which is going to be to determine what new substance that has formed is solid. So we're going to use a new tool for this. It's called a solubility chart. And in a solubility chart, you see S's and AQs. And if we look at aluminum acetate, the substance aluminum acetate has an S by it. And an S means that it's solid or insoluble. It will not dissolve in water. But barium chloride, which is going to be one of the reactants in actually 2 of the next demonstrations, is aqueous. And we're going to combine substances that are aqueous. Aqueous solutions look like this. There's something dissolved in there. And in these reactions, we're going to form what's called a precipitate, which is a new solid that has formed. And I do not know if this is the barium. I'm getting lost. That's okay. I think that this is the lead nitrate, which I'm going to use later. So in the first reaction, I'm going to take barium chloride and combine it with copper sulfate. So that reaction is right here. Copper 2 sulfate and barium chloride gives us barium sulfate and copper 2 chloride. And I've already added some barium chloride to the test tube. I'm going to add this blue solution of copper sulfate, and immediately what you see is this cloudiness, and that cloudiness is actually a new solid that has formed. So we're going to use the solubility chart to determine which of these 2 is the solid. So we have 2 new substances that have formed, barium sulfate and copper 2 chloride. What I do is I find barium on the vertical axis and see where it intersects with sulfate, which is way over here, and you see a little S there, which indicates with good strong possibility that barium sulfate is our solid. We just want to double check that copper 2 chloride is indeed aqueous, so it remains dissolved in water. So the solid ID here is the barium sulfate. In another very similar reaction, we combine barium chloride with sodium carbonate, and the barium chloride is already in there. Here's the sodium carbonate, and we produce barium carbonate and sodium chloride, and you see a cloudiness again. A cloudiness is a new solid that has formed. It's called a precipitate, and we have to identify it. So one thing that you notice about sodium is all of the sodium compounds here are aqueous. So without knowing that, I could guess that the solid's going to be barium carbonate. So let's just look though. Barium carbonate is indeed the solid. So our identity for the solid is barium carbonate. I have one more reaction right over here that is similar. This combines ammonium hydroxide and iron 3 chloride. I've already put the ammonium hydroxide in, and it has a significant odor, and I did not want to combine the wrong thing. So they're both liquids that are transparent. This indeed is the ammonium hydroxide, and you'll notice when I combine it, we get this chunky solid that has formed, and we can use the solubility chart to determine. We have iron 3 hydroxide, iron 3 hydroxide. It says that that's a solid, and ammonium chloride it says aqueous, so the solid ID here is iron 3 hydroxide. And we have one more reaction. We have to take a little look. And in this one, we're combining lead nitrate with sodium iodide. I've already put the lead nitrate in there, so I will take the sodium iodide and go ahead and drip some in. And it's a really spectacular reaction. It produces this yellow solid. And so the solid ID is going to be either the lead iodide or the sodium nitrate. Excuse me. And if you remember from the last one, we did point out that all of the sodiums are aqueous. So with a pretty good guess, it is likely that it's lead iodide. But let's check. Lead 2 iodide, and there is indeed a solid S there, which means that the identity of that yellow substance is indeed lead 2 iodide. So in this installment, you saw a series of reactions that used the solubility chart as a tool to determine which of these new cloudy substances were the solids, and that just further increases your skills in chemistry. And that's it.